We're in Miami at Florida International University. Welcome to the Wall of Wind. And it's so appropriately named, the acronym, WOW, because this really is a unique and amazing facility capable of simulating hurricane force winds. And oh, hey, Eric Salna.
Good to see you.
Hey, thanks
Welcome.
for having us. I appreciate it. This is such an incredible facility. What makes it so unique?
We go to Category 5 hurricane wind strength when we test structures. We bring water into the system to replicate rainfall. Put it all together, we replicate hurricane conditions, all to test structures, and it's all about resilience.
Well, that's amazing, and I can imagine the innovations that must come out of a facility like this.
Well,
with just the scale of it all.
The research is invaluable, and we still need to do that to move this whole field and science of wind engineering, mitigation, and enhancing the building code. This is, first of all, the room where all the clients who have a research project being tested will be in this room. And we have high-resolution cameras that will then videotape all the tests that are going on. Everything is done in here, and then over here is where we have the control room. So clients in that room, in here, this is where you would have 3 to 4 researchers then at their stations when we actually turn on the fans to then archive the data, run the wall of wind, catalog the data, and just watch the overall operation. We've had many great partners and supporters over the year, including the Florida Division of Emergency Management. But when we then became part of the NSF network, the National Network of Natural Hazard Research Facilities. That put us on a national stage. So that meant now being part of this huge network, we can get research projects from around the United States. Any faculty that may get research funding from NSF in wind engineering can come here to the Wall of Wind. Okay, Brooks, before we go in, we're going to put on our hard hats for the day.
All right.
Safety, safety, safety in this research facility as we go on in.
All right.
And go look at the fan.
Can't wait, let's take a look. All right. Well, this is it. This is the array. How neat. These are huge.
Here we go.
I didn't even realize I was standing next to the fans. I thought this was some kind of a structure. Look at the size of these.
Absolutely. As you can see, they're up against there, over 6 feet each in diameter.
Wow.
And
I'm 6'2", that makes sense. That's those are big.
What we're going to do now is open up the big barn doors, if you will, to actually get a full-scale view of the entire fan system.
Neat. All right.
Are you ready?
Hit the open button.
Yep. 3, 2, 1.
Even the scale of these doors is impressive.
This whole building is massive to be able to, encompass the wall of wind, Brooks. But we had to think resilience for the building as well. So this building was built to withstand hurricane force winds. It was built to code plus, if you will, in terms of the strength of the material. And even these doors, if a storm should be coming our way, we would anchor them in a special way as well. Each one of them had to be put specifically into its each cubby hole. That whole framing, a lot of welders here when this was built, and putting it all together. A bit on a concave, if you will, for the flow.
Yeah, what does the shape do as far as the wind? It looks like it's going into some kind of a chamber.
Just on the other side of those fans, there's a contraction zone. And that law of physics is if you contract the space, the air on the one end will speed up and come out faster at the other end.
Oh, wow.
Engineers had to figure that out. That's what got us to those Category 5 wind speed.
Incredible.